You ever see that little lock icon in your messaging apps and kind of wonder what it really means? Well, today we're going to unlock that mystery. We're diving deep into end-to-end encryption, breaking down what it is, how it actually works, and why this amazing privacy tool has sparked one of the fiercest debates in tech. Let's get into it.
So here's the plan. We'll start with a really simple analogy, the digital lockbox, to make sure we've got the main idea. Then we're going to peek under the hood and see how the keys work. After that, we'll get into the important stuff, the loopholes and exceptions. And that'll lead us right into the heart of the problem, the great moderation dilemma. Finally, we'll look at this super controversial search for a middle ground.
All right, let's start with the big picture. To really wrap your head around end-to-end encryption, or E2EE, you don't need to be a cryptographer. All you need is a simple but really effective analogy.
This breaks it down perfectly. Think about a normal message, like a text or an email, as a postcard. The mail carrier, the post office, anyone along the way can read it. No privacy there. Now, standard encryption is kind of like a clear lockbox. It's locked, sure, but the delivery service, the platform, has a master key. They can peek inside if they want to. But end-to-end encryption, that's a whole different game. That is a solid steel lockbox.
And this right here is the most important part. The platform, whether it's WhatsApp or Signal, is just the delivery service. They can see that a box is being sent from you to a friend, but they have absolutely no way to open it. They can't see what's inside. Only the person it's meant for has the key. So, how does this digital lock and key system actually work? It might seem like magic, but it's actually just a really clever system. And don't worry, we're not about to hit you with a bunch of complicated math. We're just going to talk about the ideas behind it. Okay, so it all starts with something called a public key. The easiest way to think of this is like an open padlock. You can give a copy of this open padlock to anyone you want. They can take their message, put it in a box, and snap your padlock shut. But here's the trick. Once it's locked, even they can't open it again. And that's because you and only you have the other half, the private key. This is the one and only key in the entire world that can open your specific padlock. And the crucial part? This key is created on your phone, and it never ever leaves your phone. It is yours and yours alone. You've actually seen this whole system in action. You know that verify security code screen that sometimes pops up in a chat with all those numbers or a QR code? That's literally you and your friend's phone checking to make sure you have the correct open padlocks for each other and that some imposter hasn't slipped a fake one in to spy on you. So in reality, it's this clever hybrid process. First, your phones use that super secure but kind of slow padlock system just once to securely create a brand new temporary session key. Then, for the rest of the conversation, they use that super fast temporary key to scramble and unscramble your messages. This also gives you something called forward secrecy, which is awesome. It basically means that even if a key from one session gets stolen, all your past conversations stay totally secure.
Okay, so this system sounds pretty bulletproof, right? Well, it is powerful, but it's not some magic shield that protects everything all the time. There are some really important loopholes where this protection just doesn't apply.
The biggest one for a long time was your cloud backups. Your messages would be secure while they were flying through the air, but then they'd be stored unencrypted on Google Drive or iCloud. Now you can turn on encrypted backups, but you have to protect it with a password. And if you lose that password, your backup is gone forever, which, is actually proof that the company truly can't get to it. Also, things like chats with businesses or making payments are usually not end-to-end encrypted because other people, like banks or customer service reps, need to see the data to do their jobs.
Now, the limits of this technology aren't just technical. This is where things get really heavy because E2E creates this massive societal problem. By its very nature, it puts two things we all value in direct opposition: a right to privacy and the collective need for public safety.
What happens is that end-to-end encryption creates a black box. Inside that box, communication can happen, for good or for ill, and it's completely invisible to the outside world. For activists, journalists, or just regular people wanting to talk privately, that box is a sanctuary. But for criminals and terrorists, it can also be the perfect hiding place. And this slide just lays out the two sides of the fight perfectly. On one side, you have law enforcement saying, "Look, this is blinding us. We can't investigate horrible crimes." They're demanding a technical backdoor to get access. But on the other side, privacy advocates are shouting, "No way! A backdoor for the good guys is still a backdoor." They argue that it fundamentally breaks the promise of security and could be exploited by anyone. Hackers, oppressive governments, you name it.
And we have to be honest about the business angle here, too. For a company like Meta, pushing E2E everywhere is a brilliant strategic move. Why? Because if they are technologically unable to see the content on their platforms, they can argue in court that they can't possibly be held responsible for it. It gets them out of the messy, expensive, and frankly impossible job of policing billions of private messages every single day. So you've got this intense standoff. Governments are demanding access, tech companies are building higher walls, and privacy advocates are defending them. This has led to a desperate search for some kind of technical compromise, some way to have both privacy and safety. And that search has led us to one of the most controversial ideas in tech today. It's called client-side scanning. Here's the idea. Instead of building a backdoor to break the encryption, your own phone would do the scanning. It would scan a photo you're about to send before it gets locked in that steel box, check it against a police database of illegal material, and flag it if there's a match. Proponents say, see, it's a targeted compromise that preserves encryption. But the backlash against this idea was, to put it mildly, explosive. Privacy experts didn't see a clever compromise at all. As this quote makes clear, they saw it as putting an invasive, government-mandated surveillance tool directly onto every single person's phone. They argued that once that system is built, it could easily be expanded to scan for anything: political dissent, copyrighted material, anything. It would effectively be the end of private communication as we know it. And that leaves us right here, stuck with this huge, unanswered question. End-to-end encryption offers us this almost perfect promise of digital privacy, which is something incredibly valuable. But that perfection creates a shadow, a place where immense harm can go completely undetected. Trying to figure out how to balance these two things, it's one of the biggest challenges we face. And right now, there is no easy answer.